Okay, so to kind of go off of what we did in the last unit, so we talked about polynomials that have imaginary roots. We just didn't start with an imaginary root. So this is a straight up college algebra concept. I am going to show you how to do these in the calculator just for speed. But please remember, for college algebra, you have to know how to do operations with imaginary numbers without a calculator. I do not believe... No. The college algebra calculator doesn't have the I on it, the imaginary, so you're not going to have that. So you do know how to do operations. So to be clear, okay, for college algebra, no calculator. You have to know how to add, subtract, multiply, and divide complex numbers. Okay, this is a must. Okay, however, for the speed of this video and for common assessment, for ACT, all of those things, you can use a TI-84 or a TI-83, whichever, and it will do those complex operations for you. And I'm definitely going to be doing that here because this is my only opportunity to show you how to do it in the calculator, to remind you how it's done in the calculator. So I am going to show you, but please remember that in college algebra, you don't have access to a calculator that does imaginaries for you. So if you have forgotten how to do those operations, you need to make sure you review that. And I will review briefly on here how to do that. But for time's sake, again, I'm going to be using the calculator and I'm going to show you how to do that. Don't forget, you can download the free calculator. Off Google Classroom, there is a link from Texas Instruments where you can download a TI-84 plus CE, which is what you're going to see on my screen here in just a minute. They don't have one that looks like the TI-30X2S, which is what we use and what they use for college algebra. I'm not sure why, but it's just not there. If we are in class, then you are more than welcome to use the TI-83s. Again, this is more about the process and not the imaginaries. So I've already taught you how to do operations with imaginaries. We've already done that and assessed that. So now I'm focusing more on doing the synthetic division. Okay, so number 1 says determine how many zeros each function has, then use your graphing calculator to tell how many zeros of each type. So we know that it has 2 zeros because it's a second degree polynomial, right? Descartes tells us that we should have 1, 2, or 0 positive, and negative we should have, this would be 3x squared plus x plus 5, so we should have no negatives. So we're either going to have 2 positives, real zeros, or we're going to have 2 imaginary zeros. So we can so we have 2 or 0 imaginary, right? So we can then go to our calculator, and this is just linking concepts. It's not so much that this is what we're going to be doing, but I do want to just link the concept to help you remember how graphs look. So we're going to do 3x squared minus x plus 5, and we're going to hit graph. Okay, so what does this tell me? All right, notice, does this graph touch the x-axis? So we have an upturned parabola, so the vertex is above the x-axis and it's an upturned parabola. Is this ever going to touch the x-axis? No way possible. So this is going to be imaginary zeros because there is no real number that is going to make this function 0. Okay, so just linking concepts. All right, so letter B, we know we need 3 zeros. Descartes tells us that we should have 1, 2, or 0 positives. So for negative, remember we sub in a negative, so this would be negative x cubed plus 3x squared plus x plus 3. So we have 1 negative. And then imaginary, we have 3, so it's still 2 or 0. Okay, and we can put that in our calculator. So go back to y equals. So we have x to the third plus 3x squared minus x plus 3. And we're going to graph. Okay, so notice it only touches the axis once, which is that -0. So we have that one negative that we knew for sure. But notice it doesn't touch the axis again. So it has two imaginary zeros. Okay. So letter C, number of positives. We have 1, 2, or 0. And we know we have to have a total of 3. Number of negative, we have -x cubed minus 7x plus 5. So we have 1. So then that leaves me with number of imaginary, 2 or 0. So we'll do it again. So we have x to the third minus 7x plus 5. And we're going to hit graph. And we can see that this has 3 real zeros. So we have 1 negative and 2 positive zeros. So that falls right here. So 1 negative and 2 positive and no imaginary. So for letter D, we know we have to have 4 zeros. So number of positives, we count the sign changes. 1, 2, so 2 or 0. Number of negative, so stays the same. Stays the same because it's even. Opposite because it's odd. So we have 1, 2, or 0. And that means for imaginary, I could have up to 4 because I could have 0 positive and 0 negative. And then I could have some combination of 2 and 0. And then again, some combination of 2 and 0. Okay, so let's plot this one. So we have y equals x to the fourth minus 2x squared minus 7x plus 6. And we're going to graph. Okay, so we have, let's do zoom 3, zoom out. So we have 2 real zeros. So let's go back to our standard window. So 2 real positive zeros. So we have 2 positive, and we are going to obviously have then 2 imaginary zeros as well. Okay? Makes sense? Just kind of connecting concepts between what we learned in the last unit with Descartes and what we know about characteristics of functions when we look at their graphs. Okay? So number 2 says determine if the given value is a 0 of the polynomial. So this is basically factor theorem, right? It says to do synthetic division, and if I get a remainder of 0, then it's a 0 of the polynomial, right? The only catch here is we're starting with an imaginary number. Okay, so this is not a big deal. The process, thankfully, is exactly the same. It's just adding a new kind of aspect. So negative 4i goes in the box. My coefficients go across here, so 3, 2, 1, and a constant. So 1, 1, 16, and 16. So we multiply, so negative 4i, and then add, and these are not like terms. So remember, it has to be in the very first thing. Remember, it's a plus bi form, so don't forget. Okay, now here is where you can use the calculator to kind of help you. So we're going to do negative 4i, so negative 4, and we go to second I. Oh, it helps if you're on the right screen. Oh. Okay, it's stuck, and I don't know why. There we go. All right, now we got it. Okay, so we have negative 4 second I times, we do our parenthesis, and it's 1 minus 4i, so 1 minus 4i. I, and then we hit enter, and that gives me negative 16 minus 4i. So negative 16 minus 4i, combine like terms, so my 16 goes away and leaves me with negative 4i. Now this one you should be able to do, hopefully without a calculator. A negative 4i times a negative 4i is 16i squared, and remember that I squared is equivalent to negative 1, so this would be negative 16, and we get a remainder of 0. So yes, it is a factor because the remainder is 0. So we do it the same way. 2 minus I, 3. I'm thinking that's supposed to be a 3. And 2, 1, and a constant. So we just do distributive properties, 6 minus 3i. Then combine like terms, 1 minus 3i. So then we're going to go to the calculator. So we have parenthesis 2 minus I times 1 minus 3i and then enter, and we get negative 1 minus 7i, and then add like terms, so I get negative 7i. So just to make my life a little bit easier, I'm going to go ahead and do that, and then times 2 minus I is 7 minus 14i, which definitely means this is not a factor. So no, the remainder is not 0. Okay. Letter B, same thing. So 1 minus I, 3, 2, 1, constant. Try and space them out a little bit better this time. So 2, so multiply by 2, so 2 minus 2i. Combine like terms, so negative 1 minus 2i. So I have 1 minus I times negative 1 minus 2i. And that gives me negative 3 minus I. So negative 3 minus I, which gives me negative 1 minus I. So add 2, just so I don't have to retype this, times, is it 1 minus I? Yeah, 1 minus I, which gives me negative 2, and yay, which gives me a 0 remainder, which means yes, it is a 0 or a factor because the remainder is 0, right? So one more, 3 plus I, and 3, 2, 1, 0. So 4. So 12 plus 4i. And you could do this in the calculator if you wanted. You could do negative 23 plus, and then parenthesis 12 plus 4i. So a negative 11 plus 4i. And then all you would have to do is do times 3 plus I. That gives me negative 37 plus I. And then you do plus 34. Of course, this is not as cumbersome. We're not having to change screens. Negative 3 plus I times parenthesis 3 plus I. Oopsie. Times is negative 10, and we have a factor. So yes, because the remainder is 0. So as previously discussed, it is the same thing, same process. It's just now adding in those imaginary zeros. So the same thing here. So if I know 1 0, find all the other zeros. So this is something we talked about in the last unit. I think Yes, here. So on the very first page, remember that complex solutions come in conjugate pairs. So if I know that 1 plus I is a 0, I automatically know that 1 minus I has to be a 0. And this is going to become really useful in just a second to clear out those imaginary numbers. So we'll do 1 plus I, 1, negative 5, 8, negative 9. And we have 1 plus I. So negative 4 plus I. So we have negative 4 plus I, not minus, times, what's my other one? 1 plus I. So negative 5 minus 3I plus 8. 3 minus 3I. Now I do that just so that I don't have to retype this in the calculator. So times 1 plus I is 6. 3 minus 3I. I did something wrong somewhere because it should be a 0. 1 plus I. Did I type it in the calculator wrong? Negative 4 plus I times 1 plus I is negative 5 minus 3I. It's 3 minus 3I times 1 plus I. Did I write the problem wrong? One thing about doing this not in class is you can't tell me what I did wrong if I did something wrong. 1 plus I, negative 4 plus I. So let me make sure this is actually a 0. It could be another typo. Would not be the first time it has happened to me. Trying to get stuff ahead quickly. So cubed minus 5 squared plus 8 minus 9. So it is a typo. So this is negative 3. So this is not a 0. Okay, so we will move on to the next problem. That is a typo on my part. So here, if I know 2i is a 0, then negative 2i has to be a 0. Hopefully no more typos. So 2i times 3, 2, 1, 0. So 2i times 1 is 2i. So I have negative 1 plus 2i. So we have 2i times negative 1 plus 2i is negative 4 minus 2i. So that goes away and leaves negative 2i. So then that'll be negative 4i squared. So negative 4 times negative 1 is 4. Yay, no typo. Okay, now why would negative 2i be a super good thing to do next? Okay, it's good to know these come in conjugate pairs, and it's going to be good to do that next because you want to wipe out this nonsense with the imaginaries, right? So this is a cubed and this is a squared, but I don't know how to factor that. I don't know what to do with that. So I'm going to have to use synthetic division again with negative 2i on my quotient. So 1, negative 1 plus 2i, and negative 2i, right? Bring the first term down, combine like terms, and you get plus 2i, which is 0. Okay, which is what we expected, which leaves me with this, which is an x term. So I have x minus 1 is equal to 0, so x is equal to 1. So my final answer for all of my zeros would be 2i, negative 2i, and positive 1. Okay? So again, 2 plus I. If I know 2 plus I is, I know 2 minus I is. Okay? So I have 3, 2, 1, 0. Always make sure I'm not missing a term. So 2 plus I be negative 1 plus I. So 2 plus I times negative 1 plus oops, negative 1 plus I. Negative 3 plus I will be negative 2 plus I. So this is shorter than me having to retype the whole thing. Is negative 5. And yay, another not typo, right? Congratulations. Okay, so again, we want to do that imaginary next, because although this is a quadratic, if I try and write this as a quadratic, I would not have the first clue what to do with that, right? So we want to go ahead and do that conjugate 0, and we will do 1, negative 1 plus I, negative 2 plus I. And we have 1. So 2 minus I. So my i's go away, and 2 minus 1 is 1. So 2 minus I, which goes to 0. And then this is just an x, so x plus 1 is equal to 0, so x is equal to negative 1. So my zeros are 2 plus I, 2 minus I, and negative 1. And I don't care if you write 2 plus or minus I and negative 1. Either one of those is acceptable. Makes no difference to me. Okay? Is it possible to find a polynomial of degree 4 that has zeros at 7, negative 3, 1 plus 2i, and 1 minus I? So that's 1, 2, 3, 4 zeros for a 4th degree polynomial. Do we think that's possible or not? Okay, I'm going to tell you that it's not, but why? Well, remember that imaginaries come in conjugate pairs. So if 1 plus I, if 1 minus I is a 0, then 1 plus I has to also be a 0, and 1 minus 2i. Now I've got 1, 2, 3, 4, 5, 6 zeros. Can I have 6 zeros for a 4th degree polynomial? No. If it has 6 zeros, then it is a 6th degree polynomial. Okay. Is it possible to find a polynomial of degree 4 that has zeros at 1 minus 3i and 4 plus I? So it's only 2 zeros for a 4th degree polynomial. Could they be repeating? Not repeating, but what? Conjugates again, right? So you'd have 1 plus or minus 3i and 4 plus or minus I. That would give you your 4 zeros, right? So it says, write a polynomial of minimum degree in standard form whose zeros are listed below. Okay, so we have then x plus 1 and x minus 1 and x plus 2, right? How do I know that? Well, if I know my 0 is 1, then my factor has to be negative 1, x minus 1. If my 0 is negative 2, then my factor is x plus 2. And how do I get a polynomial in standard form? Well, I multiply it out, right? X squared plus 2x minus 2, which gives me x squared plus x minus 2. And there we have it. Now for the imaginaries, I'm not going to make you multiply this all out because it gets pretty nasty, but I do want you to know how to write the factors. So if it has x, a 1 plus 2i, that would be x minus 1 plus 2i, and x minus 1 minus 2i, and x minus 3. Right, remember it has the opposite sign. Now you could simplify this in college algebra. They'll want it simplified. So you have this one, and this one. And as I said, I don't think I've never seen them in college algebra ask you to actually multiply that out, but I have seen them ask to write the factors. Okay, so just so you know, that's how you write the factors. Again, not super concerned with you multiplying it out. Okay, so minimum degree, that doesn't mean I just have x minus 4i, right? Because I know if I have 4i, I also have to have negative 4i. So that means x plus 4i. Again, not going to make you multiply that out. The point here was just to recognize that if you have a 0 of 4i, you have to also have a 0 of negative 4i. Okay? So here, that means x minus the square root of 6 and x plus the square root of 6. Now this one I do want to multiply out because I want you to see what happens. You should recognize what's going to happen. It's a difference of two squares. They're just not perfect squares because these are conjugate pairs. So I'm going to multiply it out just because I want you to see what happens. Okay, so we have x times x is x squared, and then we have a plus x square root of 6 minus x square root of 6 minus the square root of 36. Okay, so what happens to the two center terms every time we multiply conjugate pairs? They go away, and that leaves me with x squared minus square root of 36, which is x squared minus 6. Now, you know, if we set that equal to 0, you'd very easily get those two solutions, but I just wanted to kind of let you know that's what's going to happen, okay? So basically, this is it. That's all we're learning. It's combining two things that we already know how to do. We already know how synthetic division works. We already know how operations with imaginaries work. So we're just putting this together. So you have 2 handouts to complete. It's just practice. 2 handouts and then a quiz. So you have handout 1 and 2, which is practice, and then a practice quiz. Okay? So make sure, I don't really know what happened there. Let me get rid of that. Okay? So make sure that you're doing the practice. Again, huge college algebra skill. Please, for the love of all things good and holy, take it seriously. Again, you can practice with the TI-84 to kind of make the process quicker, but you definitely, if you don't remember how to multiply imaginary numbers, you need to make sure that you review that. Okay? There is a operations with imaginary numbers help on my YouTube page that you can go through and rewatch if you need to. There's also one with keystrokes, which we went through in this video, so I don't feel like you'll probably need that one. But there is a help video on operations with imaginary numbers, so you may need to go back and review that if you're a little bit fuzzy. Okay?